Alright, if you're a first year apprentice that's struggling with combination series parallel, check this out. Now there's a few different ways that this might be presented to you. If you go back and watch part 1 that I posted about 3 weeks ago, you can see another example. But anyway, here's part 2. So I drew up this schematic right here where I have 4 elements. Elements 1 and 2 are in series with one another, and elements 3 and 4 are in series with one another. And then each of these sets of series, so to speak, are in parallel with one another. What we're trying to accomplish here is we're trying to figure out the resistance total for the circuit, the series resistance of 1 and 2 and 3 and 4, along with the current total, current at each point along the circuit, voltage drop along each point in the circuit, etc., etc. Now, your first time looking at a schematic like this might be a little bit intimidating, but it's actually a lot easier than you think. Here's how you got to think about it. When you have a case like this where you have 2 sets of series that are in parallel with one another, solve the series first, and then it becomes parallel math. So what we're going to do is we're going to find resistance of load 1 and 2. So we're going to represent that as R1 and 2. All right. And since they're in series with one another, it's just going to be additive. So 35 plus 30, 65 ohms. Then we're going to do the same exact thing with 3 and 4. So R3 and 4. And since they're in series, it's just additive. 45 plus 40, 85 ohms. Now, in order to find the total resistance for the circuit, we're going to use the product over sum formula. If you don't know what that is, go back on my channel. I think in December timeframe, I posted up a parallel resistance video. Check that out. It'll make a little bit more sense, but it's going to look something like this. RT equals 65 times 85 divided by 65 plus 85. And that equals 5,525 divided by 150, which equals about 36.83 ohms. Now that we know resistance total, we can figure out amperage total, because we also know what the voltage total is, 120 volts. Once we work out current, we can then figure out what our voltage dropped across each point along the circuit is going to be. For the time being, all we need to know is that voltage total equals 120 volts. So if ET equals 120 volts and RT equals 36.83 ohms, using Ohm's law, we know that volts divided by resistance equals amps. So 120 divided by 36.83 equals approximately 3.258 amps. We can also use Ohm's law to figure out how much current is being drawn at each individual point along the circuit. So let's start with loads 1 and 2. Since they're in series, we know that the current's going to be the same. So we can just take resistance of 1 and 2, which is 65 ohms. And we know how many volts are being applied to loads 1 and 2. We haven't figured out how many volts are being dropped individually across each element, but we know that we have 120 volts from here to here because it's a parallel circuit. Obviously, it's series parallel, but for the sake of the argument, let's just pretend that this is one singular element and this is one singular element. So we can write that down as E1 and 2 equals 120 volts, and then volts divided by resistance equals amps. So 120 divided by 65 equals approximately 1.846 amps. Now we can do the same exact thing with loads 3 and 4. We know that resistance of 3 and 4 is 85 ohms. And then the voltage applied to 3 and 4 is 120 volts. We don't know how many volts are being dropped across each element yet. We're going to work that out next. But we know that from here to here is 120 volts. So E3 and 4 equals 120. And then using Ohm's law, we know that 120 divided by 85 equals approximately 1.412 amps. And then if you want to double check yourself, you can always take the amperage across loads 1 and 2 and the amperage across loads 3 and 4, add them together, and it should equal what we calculated for amperage total. Keep in mind, we're going to have a little bit of rounding error because when we put it in our calculator, it's going to spit out God knows how many decimal places, and when we write it down on the board, I've been keeping it rounded to the thousandths place values, so keep that in mind. But anyways, I'm going to go ahead and wrap this up for this video because I'm trying to keep them under 3 minutes. I don't know how long this video is going to be, but I'm going to pick up right where we left off in part 3. If you guys have any more questions, you can always DM me or drop it down in the comments below.